So now, having discussed about basic 6 functions and their respective actually graphs, so now I'd like to discuss about some of the techniques that you have to understand whenever I'd like to come up with a sketch of those graphs, and basically translation as well as the reflection cases. Now let's say we have a function, let's say we have a function y is equal to, let's say, f of x. So now how can you be able to play around with the way this function has to reflect or has to translate along actually on the Cartesian plane, that is along x-axis or y-axis and whatsoever? How should you be able to have that on? So you have to understand about this table that are going to explain everything. So this table simplifies things because it works much better because everything is expressed in the table. So it simplifies things. But next, to see on how you can be able to apply these actual techniques in the typical functions in their respective graphs. Let's say we have a function given as f of x. It should be f of x and plus c. So I should have it in this case. I should say this is a function. Now I should say graph obtained. So now the graph obtained. Let's think of the first case, which is given as 1. Let's say 1. We have a function y is equal to fx and a plus c. So how should we be able to obtain the graph of the function if this is the case? So now you can see that we have a function f of x being added to a constant which is given as c, and c is alone there. It is not part of f of x. So if that's the case, then c is said to be the translation determinant, but it is along y-axis. So as it stands here, it means c is said to be the translation determinant, but should be y-axis. So now we have to translate the graph c units vertically upwards. So the graph has to be translated about c units vertically upwards. So which means if c is given as 2, it means we'll have to translate the graph about 2 steps vertically upwards. So that's what it means there. So which means we'll have it as translate c units upwards. That's what it means there. And what if we have another case? So this happens because a constant is around there. What if you have y is equal to f of x, let's say, minus c? So now this is the opposite of this one. So now since c is given as the negative, it means the graph has to be translated c units downwards. So that is the vertically, actually that is the opposite of this one. So now we have the c which is alone, and that is negative. So the graph has to be translated c units vertically downwards. So which means from the origin, the graph has to go down about actually c units. So that's what it means there. So which means we'll have it as a graph will have to be translated c units or downwards. That's what it means there. And we have another case. Let me just have to. And we have, let's say, a y is equal to f of x plus c. So what it is here? What does it mean here? So now you can see that a c is a part of actually x. Hence, a c is said to be translation determinant, but now along x-axis. So this is the translation determinant along x-axis. So now since c is actually positive, and it works actually opposite with the positive c which is along y-axis. Now what will happen is that the graph will be translated, should be a units to the left. So the graph will be translated c units the graph will be translated c units horizontally to the left. So that's what will happen. Let's now have it as a c units to the left. So which means if c is positive, it means the graph has to be translated to the left, that is to the negative direction. So unlike here where c is positive, the graph has to be translated to the positive direction of the x-axis. And likewise, a case number 4, y is given as f of x minus c. So should be this. So minus c. So now this is the opposite of this one, where the graph has to be translated c units to the right, since c is given as the negative. So the graph has to be translated to the right. So bear that in mind. And we have another case which is given as the case number 5. So what's that one? We have y is equal to negative f of x. So now for that case, it means the graph will have to reflect in the x-axis. So the graph will have to reflect in the x-axis in this case. So which means, mind you, f of x, it is the same as y. So if we have negative y, it means the graph has to reflect along x-axis. Now it is like the graph has to reflect opposite to y, which is now x. So bear that in mind. Now reflection along x-axis. So take note of that. And finally we have another case. Let me just have to create some space here. So what's that case? And we have a 6 being given as y is equal to f of negative x. So if this is the case, then the graph has to reflect along y-axis, and which is the opposite of this one. So which means here, what is the negative is x. So while here the negative was given as y. So that's the essence behind. So the graph has to reflect along y-axis. Reflect along y-axis. So you should have to understand that one. So mind you, these techniques are applied for all functions that we discussed. So the next to see on how we can be able to come up with the sketches, the graphs using these techniques. And they are applied for all functions that we'll be able to come across with. So mind you, if we have this case, it means the graph has to be translated actually vertically upwards, that is along y-axis, and vertical downwards along y-axis, and some sort of actually a c units to the left, much as we have c part of x, and it works opposite. Instead of having to the right, we'll have it as to the left. And also here we'll have it to the right, and a reflection along x, and this is along y. So take note of that.